Hey everyone, welcome back. In today's video, we are going to dive deep into building a real-time anomaly detection system. This system can detect unusual pattern in your data and will be coding it from scratch. And also, we are also going to visualize the result to make the detection clear and actionable. So whether you're working in the security, IoT, or financial monitoring, anomaly detection is crucial. Today, we'll focus on how to detect anomalies in the time series data. And by the end of this video, you will have a complete solution running and ready to handle the like a real-time data. So before we dive into code, let's first understand what we are building. In simple terms, our system will receive time series data, process it to detect anomalies, and output the result. So we'll break it into following steps. First, the data collection. We'll simulate the real-time data streaming. Second is the pre-processing. We'll clean and normalize the data. Third, we'll implement an algorithm to detect anomalies. Fourth, visualization. So we will visualize the data and anomalies in real time. So to follow along, you should have a basic understanding of Python and machine learning, and you will also need need a few libraries like pandas for data manipulation, NumPy for mathematical operations, matplotlib for visualization, and scikit-learn for machine learning algorithm. I hope you have all this installed. Now next, we are going to import the libraries. So let me import this and let's stimulate some real-time data. So we will generate some sample time series data and introduce anomalies manually for testing. So here's the code to generate the data set. So this is a function which generate the data set. The values is 1000 by default, and it will generate two things, the time and the data. And as you can see there, I've added the anomalies in the data where the rows starting from 100 to 120, whatever value is creating all the random values will be added 20 20 to it, and there I'm subtracting 30, and it will return the data frame. So if I run this, and let's see the data. So in the above code, we generated 1000 data points with random noise and reduced two anomalies at specific positions. So this will simulate a real world data where unexpected spike or drop can occur. Next, we'll pre-process the data. For real-time system, you often want to clean and normalize your data before detecting anomalies. Let's start by checking for any missing values and handling them. So this will pre-process the data. We are adding converting time to date time, handling missing values. And the next one, we are normalizing the data using Sanders scaler. So normalization is essential because it ensures that the anomaly detection algorithm is not biased by the scale of the data, right? So we have created a new column called scale values by fitting the values to the scaler. Now it's time to implement the algorithm detection, anomaly detection algorithm. For this, we will use the isolation forest algorithm from scikit-learn. So this algorithm works well for high dimensional data and can detect anomalies by isolating them in the data. So we'll set the contamination parameter to 0.05, which means we expected 5% of the data to be anomalous, and the model assigned the label -1 for anomalies and 1 for normal data. So as you can see, the last 5 rows, so the data seems to be normal. Now let's visualize the anomalies and the normal data point using matplotlib. So let me run this. So this code plots the normal data in blue and detected anomalies in the red. By looking at the plot, we can see where the anomalies are in the time series, right? These are the anomalies. Now that we have everything set up, let's simulate the real world data streaming in real world scenarios. So you will be receiving the live data, but here we simulate it in chunks. So in the loop above, we stimulate the stream of 100 new data, and this 100 new data every few seconds, and pre-process the data, detect the anomalies in real time, and then we will visualize just like you would with the live data. So if I run this, so after every second, you see the new data will be generated and anomalies will be detected. See, and that's it. You have built a real world anomaly detector system that can identify the unusual pattern in the time series data. You can also apply this to various application like fraud detection, um, or the monitoring in the IoT sensors, or tracking any data that evolves over time. Yep. Thank you for watching. I will see you in the next one.